In this section, we're going to start looking at the functional group known as the alkenes, which are carbon-carbon double bonds. In many cases, you'll see them referred to as olefins, but this is an older term that's starting to kind of fall out of favor. The general formula for an alkene is CnH2n. So let's compare this to the alkanes that we've already talked about. So let's look at a simple alkene. Here's propane with the molecular formula C3H8. And that's because being a saturated alkane, it follows the general formula CnH2n plus 2. But if we add an alkene to this, now instead of the ane ending, we would call this propene, and it has the ene ending because it's an alkene. The molecular formula for this is C3H6 because it follows the general formula CnH2n. So what does that tell us? Well, going from propane to propene, we've lost 2 hydrogen from the formula. Well, every time you lose 2 hydrogen from the saturated formula, that is an unsaturation, which is something we're going to talk a little bit about here in just a minute. Now I want you to consider this 4-carbon alkene where the double bond is in the middle. And remember that the double bond acts as kind of a lock in the molecule, and it locks the atoms in place. So this structure here is a bit ambiguous, but there's actually 2 variations of this we can draw. We can draw it like this, or like this. And with this, what you want to see is that, let's also go ahead and draw in the hydrogens, although we can leave them implied. Okay, and then from here, what you want to essentially do is think about your double bond as almost a plane. And what that does is it lets you see the relative orientation of your groups. So if we draw just a straight line to make the double bond a plane in both cases, what we can see is that in the top structure, the 2 groups are on opposite sides of that plane. That is a transalkene. In the bottom structure, the 2 non-hydrogen groups are on the same side, and that is a cisalkene.